All right, so we have a charged particle moving through a magnetic field, and we're given its speed, and we want to calculate the force, the radius, and the period of its orbit. Again, I'm just using different numbers than we did in the other practice test, but it's good to get some problems sort of learned very easily, and this happens to be one of those. So this, of course, is our charge. This is our field. This is our speed. And we have a mass. Now, not all numbers are going to be used in all formulas. So when we get the force on this particle for part A, the force is going to actually be Q times V times B. And that's going to end up being Q, which is 3 times 10 to the negative 6th, times V, which is 5 meters per second, times the B, which is 4. When we actually work all of this out, I believe we're going to get 60 newtons worth of force. All right, now for the second part, we want the radius of the circle it travels in. We're going to grab a formula from the formula sheet, R equals mv over qb. I believe I have G period prove this formula as a proof. Not that difficult, but a bit tedious. And now I'm just going to throw in the numbers that we have. I shouldn't say tedious. It's more, it's a necessary part of life and engineering. All right. To kind of know where formulas come from, because sometimes you have to change them a little bit in the real world. So this is going to be 0.05 divided by 60. Actually, no, 0.05 divided by, you know what, I'm actually going to check all my numbers here. I don't trust any of them. So let me just go back to the force formula. Let's see. Oh, and here, this should say 4 times 10 to the 5th. There. So, when I'm actually checking these formulas, we'll get 3 times 10 to the negative 6th times 5 times 4 to the 5th. Sorry, so this is actually 6 newtons, 6.0 newtons. And then this here, when we actually get the radius, divided by I'm getting 0.041 for the radius. And then when we get the period, it's going to be T equals 2 pi m over qb. Once again, we'll need to be careful to put our numbers in. So m is 0.01. And Q and B we plug in from before. When we actually get this period, it's going to be 2 times m divided by Q divided by B. And that's giving me 0.052 seconds. All right. Now, we have a 0.08 meter wire. It experiences a magnetic force of 8 newtons, and we want the magnetic field acting on that wire. So we have F is ILB, and that's going to be 8 Newton force. It's got a current of 0.003 amps. The length is 0.8, and we're trying to get B. So when we work all this out, I ended up getting 3,333 Teslas as my value for B. All right. This we actually did in G period on the previous set of videos, so I'm going to be a little bit quicker about it. Basically, we're going to have mv squared over r is qvb. One of the v's will cancel. When we isolate r, we're going to actually end up getting mv over qb when we isolate. On a real test, I'd want to see you multiply both sides by r, like that. Oops. And if you were to do that and then just jump to the second step, I'd be totally okay with that as the answer. So that's problem 1.